Hi all, Dmitry is here. In this video I will test Lexman rechargeable batteries, as you asked me in the comments to the previous video. It will be quite interesting to compare rechargeable batteries with normal Lexman alkaline that we already tested before. So here I have a pack of 4 Lexman rechargeable batteries. Capacity is 200 mAh. They came as pre-charged, so I will start testing without initial charging. After first round of discharge I will charge them and test again, so we will be able to see how good they can hold charge in storage, because right now they are from storage and some capacity already lost, so let's check how many. I will mark them with paper tape to distinguish on one from others, to test exactly same cell with exactly same current in different rounds. And for 500 milliamp hours, for 500 milliamp discharge current, I will do several cycles of charging and discharging just to check if characteristics will change with cycles, or maybe they will not change. So let's start. So here our Lexman rechargeable are marked and ready to test. Let's start with first one and 0.1 discharge current. And by the way, I lowered cutoff voltage to 0.6 volt just because the nominal voltage is 0.2 volts and the working voltage can be a little less than alkalines, especially with high current. So theoretically our IMAX can shut off too early, but we will see on the diagrams if this is a case or not. So let's take a look. Let's install first one and check. Okay, our first Lexman rechargeable installed. Let's start the testing. And as you can see, voltage is lower than it was on normal alkalines. But let's see how flat that curve will be or will not be. So yeah, there is some difference from normal alkalines. Let's check and compare. Okay, first discharge is finished, and as you can see, capacity was about 1400 mAh, which is about 68% of full rated capacity. It could be better, but I guess it's okay. It's not too low, but definitely this batteries is not low self-discharge ones, or maybe they was in storage for really prolonged time, we don't know. But anyway, you can buy them and use right off the shelf. Let's try discharge with 0.2 amps. New rechargeable battery is installed. Let's start the test with 0.2 amps. Okay, 0.2 amp discharge is finished, and we can see capacity is about exactly the same, just it was with 0.1 amp. So it looks like this current increase actually not affect the capacity. This current's battery can hold really well, and as you remember, with alkalines we already had some capacity drop with increasing current from 0.1 to 0.2, but here capacity is almost not changed, which seems to be good. Okay, let's test another battery with 0.5 amp. Okay, next Lexman rechargeable is installed, and let's start checking 0.5 amp current. Okay, it goes, and we have some voltage drop already. So let's see what graph and what capacity we will have. .5 amp discharge finished for Lexman rechargeable battery number 3, and as you can see there is some capacity drop with current increase, but this drop is about just 10%, so it looks like rechargeable batteries holds high current discharge much better than alkalines. Let's perform same discharge test for battery number 4. Okay, let's check the last one, Lexman rechargeable. It's number 4 here, and for this battery let's just do half of ampere discharge and then immediately recharging. So for battery number 3, I did slowly discharge with 0.1 amps to fully drain the battery before charging. Here I will not do this, so just let's discharge it quickly and charge. And I will do several cycles. I think maybe I will not film every cycle, but I will do several cycles, and let's compare the graph. If there is some memory effect, if you need to fully discharge the battery before charging it, or maybe newer ones don't have a memory effect, or at least it's not really strong, and you can put it in charger after using and don't think about it. So it's getting interesting. Let's check it. Okay, here we go. And we have finished 0.5 amp discharge for battery number 4. As you can see, capacity is about the same like it was with number 3, which is normal because we have exactly the same start conditions. They was from the same pack, and for now they has same history. But right now I will charge this one without fully discharging it, so we will check if they have memory effect or not. And let's start another round of discharge testing with freshly charged first battery. So let me quickly change them. Okay, I've installed Lexman rechargeable just yesterday charged, so it sit about 1 day after charging to get some rest. Because nickel batteries tend to quickly lose some capacity in 1 day after charge, and then they hold it more or less good. So it loses that initial capacity, and now test should be fair. So I will film next series of discharged just after charging, and I will do little more tests, but I will not film them. You will just see the results in resulting diagrams. So okay, quickly let's start discharging for charged Lexman rechargeable 0.1 amps. Let's go. As you can see, voltage is much higher than it was in previous tests. But okay, let's compare the graphs. Okay, 0.1 amp discharge is finished for Lexman rechargeable, and as you can see, capacity is a bit higher than it should be according to specs, so it seems really good. Let's check another cell with 0.2 amps current. Okay, another Lexman rechargeable is installed, then let's start 0.2 amp discharge. This is freshly charged also, so it's not from storage, I charged it. Let's check how it will perform at 0.2 amps. Okay, 0.2 amp discharge is finished. As you can see, capacity is a bit less than 2000 milliamp hours, but it still looks completely okay. Let's check third battery. Okay, third battery is installed, and just a quick recap, this third battery was fully discharged with low current 0.1 amp before charging. Let's see what we will have with 0.5 amps here. So significant voltage drop, but let's take a look what do we will have. Okay, half of ampere discharge is finished for Lexman number 3, and again capacity is quite good. Let's perform last test in this video. Let's discharge Lexman number 4 that was charged without proper slowly discharging. This more looks like normal using conditions. So for example, you have a digital camera, flashlight and so on. It shows that the battery low, or it just turns off, and you will just put batteries in charger. You will not discharge them in low power something. So let's check how Lexman number 4 will act like. Okay, setup is ready, and this will be last test filmed in this video. I will do several more cycles for each of that cells, but I will not film them because I think it will be too boring. And you will able to see the results in final tables. So let's start final discharge for this video. Okay, it's going. Okay, last discharge is finished, and as you can see, capacity is quite good, but it's lower than it was for previously fully discharged cell. This difference is just about 1%, but I will do a few more cycles, and in final diagrams you will see if this makes some difference after a number of cycles, not just after one, or maybe not, maybe it's just some statistical deviation. So finally, all tests for Lexman rechargeable are finished, and we have some results. Here you can see graphs of 0.2 amp discharge. I did 5 rounds, and you can see all 5 rounds results here. This one is initial state of the batteries. They came as pre-charged, so I did first test without charging, and you can see it's here. It's really shorter than other ones, but all others looks about the same. Interesting moment here is for next attempts, the most capacity was on second attempt, and then with growing number of cycles, capacity slowly drop. Not too much, but this is interesting. I expected to see different picture. I expected capacity to rise because of like it's battery training, because of new battery maybe need to be formed, but actually no. As you can see here, capacity actually dropped with cycles, So this is pretty interesting. All other graphs for other discharge currents actually look the same. Just length of this curve is a little changes with the current, because with the high current you have lower discharge time, but most important, the form of the current is about the same. Let's take a look on joint graph. Here we have curves for 0.1 amp discharge current, 0.2 and 0.5 amp discharge current, one for battery that I discharge fully after each cycle, it's yellowish one, and green one is a battery that was not discharged with low current after each cycle. As you can see, in this case we have a bit lower capacity, but actually not too much. I guess there is some like it's called memory effect, but it seems like it not a big deal with number of cycles, about 5 like I did. So it looks like if you want to see that memory effect you need a number of cycles, maybe I don't know, 15, 18, I don't know, lots of them. But with just 5 cycles it's not a big deal. So here we have 0.2 amps and here we have 0.1 amp. As you can see, forms of the curve, it's more or less the same. We have quickly voltage drop at the beginning, and then we have something like plateau, and then voltage drops rapidly. So most important, most interesting things here, let's compare Lexman rechargeable with Lexman alkalines, with Lexman intensive that we checked before. Here I have graph with both of curves. Here is 0.1 amp for Lexman alkaline. Here is 0.2 amp for Lexman alkaline and 0.5 amp for Lexman alkaline. And this 0.5 amp for rechargeable, 0.2 amp for rechargeable, and 0.1 amp for rechargeable. And this actually is pretty interesting. As you can see, for 0.5 amp capacity, and by capacity I mean this time length of this curve, capacity for 0.5 amp for rechargeable much higher than for alkaline. This is okay, this was expected. For 0.2 amp is about the same, but at this point voltage of alkaline drops below voltage of rechargeable, and this point is at the beginning of discharge. So here actually we have voltage of rechargeable is higher than alkaline, so rechargeable performs better here, but maybe this is okay because 0.2 amps is more or less high current. But let's take a look at 0.1 amp. What do we have here? Yes, capacity for alkaline is a bit higher than for rechargeable, but difference is actually not very big, and this is surprising. I thought that for rechargeable we will have capacity much lower than for alkaline, but no, it's not about the same, but maybe 10-15% difference, not too much. But look at the voltage. At this point Lexman rechargeable begin to perform better than alkaline. So alkaline works better than rechargeable only here, maybe in 30% of all discharge. Then rechargeable works better. So this is surprising for me. I thought that at low current alkaline will outperform rechargeable, but looks like no. alkaline outperforms it only here and maybe here, but here we have really low voltage, so probably your device will not work here. So it looks like for almost any cases it will be better to buy rechargeable one. I mean something that consumes more or less high current. If you have, for example, electronic watch, electronic clock that needs one battery for maybe half of a year, here definitely buy alkaline. Don't think about rechargeable because they have big self-discharge. But if your device need one battery per maybe several hours of work, so it's some flashlight powerful, or I don't know, some game controller, digital camera, of course. So in this case it looks like it's almost always better to buy rechargeable batteries, and normal cheap alkalines will work worse. This is a bit surprising for me, but here is the graphs. So thank you for watching. I hope this video was interesting for you. If you have some comments, you have some ideas, please tell me in the comments. And please tell me if video quality in this video is better or maybe it's worse than on previous videos. Thank you and bye bye.